the moment we have these 7 topics listed: homologous series, esters, greenhouse effect, alkanes, alkenes reactions, polymerization, relative atomic mass questions, and colors of indicators for acid bases and titration questions in general. Any other topics other than these? If not, just give a thumbs up. All right. Okay, yeah. Fine. Okay, now here's the good thing about this Feb March paper. It covers polymerization, it covers RAM questions, it covers some of the reactions, but it does not cover greenhouse, esters, homologous, or indicators. So while we are going through this paper, we will have covered 3 of the 7 topics you guys have mentioned. But after we are done with the paper, we will also go through the remainder. So, by the way, have any of you already solved the Feb March 2026 paper? Because it isn't officially available yet. Right, I'm guessing none of you have. All right. Now, the thing about this paper is I have solved this paper this morning, and I thought that the paper was fairly standard compared to any of the more recent papers, which have been a bit more difficult, I would say. This paper went fairly straightforward. All the questions were more or less just directly from your notes. So let's see. When we are solving this paper, I'm going to take a different approach. I'm not going to answer everything. Rather, I'm going to ask you guys to answer some of the questions. Now, obviously, if some of you are confused, we will explain them. But generally, it's more so going to be a questionnaire of sorts rather than just me solving the paper blindly. All right. So if we just read through the first question, what do we have? We have a question related to metals. So symbols of elements with atomic numbers 21 to 30 are shown in the table. So we have this table and it goes from scandium to zinc. So from 21 to 30. Okay. And we are asked to answer using symbols from this table. Okay. And in that case, what's the first question? Give the symbol of the element that is a catalyst in the Haber process. Now, students, what should this be? This is pretty much the easiest question you could probably start with. Yeah, Sam, you are correct. Iron. Fe. Now, you must be very careful over here. Like, don't get overconfident and think that, all right, it's such an easy question, and I'll write iron. That way, a lot of students would end up making a mistake because they were very clear about mentioning the symbol. Now, alternatively, they could also ask, instead of symbol, name them. Be careful about that as well. Like, they will give you the symbols over here, but the question will say name. And in that case, if you write the symbol, then you lose the mark. So be very careful about this distinction of whether it's a symbol or a name. So yeah, the first one is correct. And then the next one is used to galvanize iron objects. What should this be, students? And I would prefer if different students answer different questions. Yeah, the two of you are correct. It should be zinc. All right. And then the next question. And another thing about galvanizing iron actually provides two, two levels of protection. One of them is sacrificial protection, and the other one is the barrier method. I'm pretty sure when you have covered the transition elements chapter, you have learned about different ways to prevent rusting. And one of them is sacrificial protection. The other one is the barrier method. The barrier method is a physical process. The sacrificial protection method is a chemical process where you use a more reactive metal that will react in place of the metal that you're trying to protect. So that's just a brief overview. All right, let's look at the next question. As a blue anhydrous chloride used to detect the presence of water, what should this be? বাবু একটু আস্তে কথা বলো, আমি ক্লাস রেকর্ড করতেছি। হয় অন্য রুমে যাও আর না হলে অন্যদিকে তাকাও। Yes, the two of you are correct, Samuel and Arya. It should be cobalt. But can any of you tell me what will it turn into after the reaction with water? All right. Isabella is answering light blue. Samuel is answering pink. What about the chemical formula? Instead of the color, what would be the chemical formula of the substance or the compound that is produced after this reaction? Okay, yes, Samuel, we did use cobalt chloride, but what's the specific formula? Any guesses? Any answers? Because here's the thing. Over here, all right, Liat, you wrote cobalt chloride. Arya, yes, you are correct. It should be cobalt chloride with 6 water molecules attached to it. So the reaction that is going to happen is something like this: cobalt chloride plus H2O, and it's going to give you hydrated cobalt chloride. And it is going to have 6 water molecules attached to it. And these water molecules that are attached to this salt is called water of crystallization. Now it's called water of crystallization. And about the color, so initially it started off with blue, and at the end of the reaction, it's going to have a pink color. So cobalt, when it reacts with water and has water of crystallization attached to its crystal, it turns pink. And it's very important you guys know this reaction. I see that many of you are struggling to actually write down what is going to produce after the reaction. So please remember this, because again, over here, they just ask for the name. But in your exam, they could also ask you to write down the chemical reaction as well. And while we are at it, also remember the equation for copper sulfate. So copper sulfate plus 5H2O is going to give you CuSO4 dot 5H2O. And the color change for this one will be, it goes from white to blue. So these two are the only water of crystallization reactions that you guys have in your syllabus. And the color change is very important. So does anyone have any questions from here? If not, just give a thumbs up and we move to the next part. All right. So what about Isabella and Chelsea? All right. And Isabella, you mentioned that it's going to be light blue, but it's going to be pink, unfortunately. All right, let's move to the next part. And this is a reaction of alkenes question. So it is a catalyst used in the reaction of alkenes with hydrogen. So before we actually answer the question, since some of you did raise the concern regarding alkene reaction, let's see what happens over here. So you have an alkene and hydrogen is being attached to it, or hydrogen is being added to it. The type of reaction for this one is addition. And what is going to happen is the double bond is going to break and two hydrogens are going to get attached to your alkene. So at the end, the product that we will have is an alkene. So this is the reaction that's happening over here. But they ask for the catalyst. So students, can anyone tell me what should be the catalyst for this reaction? Yes, Liat, you are correct. It should be nickel. Is it clear for the others as well? All right, Samuel. What about Isabella and Chelsea? Okay. Chelsea, are you there? Can you hear me? All right. Okay, do you want me to explain the reaction or do you want me to explain the catalyst? Because the thing about the catalyst is it's just a metal that is handpicked for this reaction because it speeds up the rate. For there, you don't really have to understand anything. It's more so you just remembering the catalyst. But for the reaction itself, yes, thank you. For the reaction itself, here's the thing. Alkenes have a double bond. They have a carbon-carbon double bond, to be specific. Now, what happens over here is when you add hydrogen to an alkene, the hydrogen wants to attach itself to the carbons. Now, we know that the carbon can only form 4 bonds. And if you look at this structure, each carbon already has 4 bonds, 1, 2, 3, and 4. So in order to form a bond with the hydrogen, it needs to get rid of one of its bonds. And that is what ends up happening. It gets rid of its double bond, and then the hydrogen gets attached to the 2 carbons. And that is why at the end, if we check, now all the carbon-carbon bonds are single bonds, and 3 hydrogens are attached to each carbon. So the new formula is C2H6, which we know is just the formula for ethane. So when an alkene reacts with hydrogen, it undergoes an addition reaction. And at the end, you have an alkane as your product. And this is the only product for this reaction. Students, remember, in an addition reaction, you only get one product. If it was any other kind of reaction, let's say a substitution reaction, then you could expect multiple products. But for addition reactions, it's always one product. Is this clear for all students? All right, Chelsea. Okay, let's move to the next part in that case. So E says forms a green precipitate when aqueous sodium hydroxide is added to aqueous solution. Yes, Sam, you are correct. It should be chromium. Now, how would you differentiate between iron and chromium? It's for this part. It dissolves in excess aqueous sodium hydroxide. If it was iron instead, it wouldn't dissolve. But for chromium, we know that it is going to dissolve. And the way you remember these ion tests is from your syllabus. Near to the end of the syllabus, you have an entire list of every single ion test, gas test, and flame test required. So if you just go through that, you should be fine for this one. All right, let's move on to F. Forms an ion that has 24 electrons and a charge of 3 plus. So if you just look at this one, so it said that the ion has 24 electrons and a charge of plus 3. That means it has lost 3 electrons. So in that case, the atom should have 3 electrons more. Hmm? No, in your syllabus, if you look, the ion test that is provided for chromium is, oh, for cobalt. The answer for this one is chromium, by the way, Leah. You don't have an ion test for cobalt as part of your syllabus. The only cobalt reaction that you guys have is for, wait, I'm confused now, Leah. What is your question? Is it regarding chromium or is it regarding cobalt? All right. If it's regarding chromium, then the ion test for chromium that you guys have in your syllabus is for the green colored compounds. It might have other colored compounds, but you need not worry about that for your syllabus. If you go to AS, then you might require it from time to time, but for IGCSE, you need not worry about it. All right. Okay. So we were talking about number of question F forms an ion that has 24 electrons, and we already know it lost 3 electrons. So 24, if it lost 3, that means the atom had 3 more. The atom had 27. So 27 is for cobalt. So we can see that some answers are being repeated over here. C and F are the same. Now, students, do not get worried that why am I getting multiple answers of the same answer multiple times. It's completely fine. And they themselves mentioned that each element can be used once, more than once, or not at all. Is F clear for all students? Does anyone have any questions regarding F? Okay, Samuel is fine. Maria, what about Isabella, Chelsea? Yeah. Okay. Let's look at G. Forms brass when mixed with copper. What is the name given to brass? By the way, Samuel, EI. Yeah. All right. But what is the name given to brass? What is brass? Yeah, it is an alloy. Now, for brass, Sam mentioned that it's tin, but actually in brass, what we are doing is we are mixing copper and zinc. These two metals are mixed to produce brass. And what is essentially happening is the copper atoms have one size, the zinc atom have another size, and this ends up giving the brass different properties from the metals. It is generally stronger than the individual metal, mainly because the atoms cannot slide in the layers like it would have if the atoms or the regular atoms were just arranged in the metallic bonding. So in an alloy, since there are different metal atoms present, they can't slide on top of each other as they would compared to your regular metal. So for G, the metal that is used to form brass is zinc. Sam, it's not tin. Do make the correction. All right. So that is the first question over here. It was worth 7 marks. Pretty straightforward, I would say. All right, let's move on to number 2 and let's see what do we have over here. Aluminum and indium are metals in group 3 of the periodic table. Aluminum is extracted from its purified main ore. Purified ore is mainly aluminum oxide, which we know is Al2O3. Yeah, that's fine, Samuel. All right. During this extraction process, aluminum oxide is broken down into its element. Name the main ore of aluminum. So, what is the name of an aluminum ore? Yeah, Leah, you are correct. It should be bauxite. Oh, definitely do not write Al2O3 over here. That's the formula. That's not the name of the ore. Okay. Name the process in which aluminum oxide is broken down into its element. What should this be? Electrolysis. Now, what happens in the electrolysis? They did not ask for the equations over here, but let's just have a quick recap so we know that we are all on the same page. So Al3 plus ions are present. The compound that is going to be electrolyzed is Al2O3, and it's molten Al2O3. So Al3 plus ions, they're going to gain 3 electrons to give you aluminum, the one that you're desiring. And then oxygen, O2 minus, is going to be produced in the anode. So this is the anode equation, and this is the cathode equation. Do all of you know these equations already? All right. And another thing, students, at the anode, we have to replace it very frequently, or we have to replace it regularly. Can anyone tell me why do we have to replace it regularly? Yes, Sam, you are correct. CO2 forms because the anode is made of carbon, and what happens is the oxygen and carbon react, which is why the carbon is lost in the form of carbon dioxide. Okay, that's fine. And then let's see. Name the substance which is added to aluminum oxide to reduce the operating temperature of this process. Yes, Samuel, you are correct. It should be triolite. By the way, are the rest of the students understanding as well? I see that Samuel is answering very quickly, but do let me know if it's going a bit too fast. Okay, let's look at B. Aluminum oxide reacts with both acids and bases to form salts. State the type of oxide that reacts with both acids and bases. What should be the name of this oxide? Yes, Liat, you are correct. It should be amphoteric. Besides aluminum oxide, can students name any other amphoteric oxides? Okay, zinc. Anything other than this? Lead oxide is also amphoteric. So zinc, lead, both of them are amphoteric along with aluminum oxide. But generally, you guys are only asked about aluminum oxide or zinc oxide every now and then. Okay, let's see the next question. State the name and give the formula of the salt formed when aluminum oxide reacts with dilute hydrochloric acid. So the type of reaction that's happening over here is an acid-base reaction. So aluminum oxide is behaving as the base, and HCl is the acid over here. So we know that we're going to get a salt and water at the end of the reaction. So what should be the name of the salt? Yeah, aluminum chloride. And the formula is AlCl3. And the reaction is also something that you should know how to write. So Al2O6, sorry, Al2O3 plus HCl is going to give you AlCl3 plus H2O. And then you have to balance it. So I see that I have 2 over here. So I'll bring a 2. And then I see that now I have 6 of chlorine and I have 3 oxygen over here. So to balance it, let's bring a 3. That way the oxygen is now balanced. And I see that I have 6 hydrogen as well. So if I just had a 6 over here, this is the balanced equation. And if you were to write down the state symbols, aluminum oxide is insoluble, so that's a solid. HCl will be aqueous. AlCl3 is a soluble salt, so it's aqueous, and water is just liquid. So this is the reaction that is asked for in this question. Does anyone have any questions from here? The reaction should be something that you remember. Don't just rely on the fact that, okay, and there was a question. What is it? Reacted with a base. All right. For example, let's consider this Al2O3 and NaOH. The product of this reaction is called sodium aluminate. It is something like NaAlOH4. And you'd have to balance it out afterwards. But the main thing is they won't ask about an aluminum oxide and a base reaction because this reaction is for AS. So when you go for AS chemistry, there is a separate chapter called periodicity where you will learn about such reactions. But for IGCSE, you don't really have to bother about this. They will mainly ask you about simple acid-base reactions. And if you look at number 3, you do have this question, but over here they gave you the product. In this reaction, you have multiple products possible. Sodium aluminate is one of them, and this is another one. So if you look at this one, the salt formed when aluminum oxide reacts with aqueous sodium hydroxide is sodium aluminate, NaAlO2. Complete the equation for the reaction of aluminum oxide with aqueous sodium hydroxide by inserting the missing formula and balancing the equation. So the good thing about this is they gave you the product itself because that way you don't have to figure it out. Now here's the thing. We know that this is an amphoteric oxide, so this one is going to be basic. Sorry, this one is going to behave as acid and this one is going to behave as a base. So this one is the salt, and we know that when an acid reacts with a base, and it's going to form a salt and water, H2O. But the main thing is balancing this equation. So I see that I have 2 of aluminum, so that means I will need a 2 over here. And when I add this 2 over here, I notice that I have 2 of sodium as well. So that way I will have 2 in front of sodium hydroxide. And then the last thing that I have to look for is the balancing of oxygen. So I see that I have 5 oxygen on the left-hand side. So I will need 5 on the right-hand side as well. And if I just check 2 times 2, that's 4 oxygen. And then a 1. So I do have 5 oxygen as well. And then lastly, just to confirm the hydrogen, I have 2 hydrogen and I have 2 hydrogen as well. So to balance this, you just have to add 2 2s over here. This is one possible reaction, and there is another one as well. But again, you don't really have to know that for IGCSE. In IGCSE, they're very lenient in terms of reactions. Most of the time, if it's an unknown reaction, they will give you the products. You don't have to figure out anything by yourself. Does that answer your question, Samuel? All right. And the one about sodium aluminate that I was talking about, the full reaction, in case you're curious, we write water separately and NaLOH4 like this. And the balancing for this one is a bit tricky. It's 2, 3, 2. When you're sitting for your AS levels, you'd have to like remember this reaction and the way it's balanced. For IGCSE, this is way too complicated for you to understand. So you can check it out if you want, but not really necessary. All right. Write the formula of the anion in NaAlO2. No, Arya, ammonia is not amphoteric. Ammonia is a weak base. Amphoteric oxides are generally just metal oxides. So ammonia, since it's not really consisting of metals, it's not an amphoteric oxide. Okay. Write down the formula of the anion in NaAlO2. Yes, Samuel, you are correct. It should be AlO2. Now, I would suggest give a bracket and write a minus. That way, it is clearer because a lot of students might make this mistake. They will write O2 minus like this, or they will give the 2 minus as part of the charge. So, to be on the safe side, give a bracket, give a minus sign, or be very clear about where the minus sign is going to be. It's going to be on top like this. All right. See what do we have in the later part. State the number of occupied electron shells in an atom of indium. And they told us the atomic number of indium as 49. So what we will do now is go all the way down, look for indium in the periodic table. And we see that this is indium. So how will we know how many electron shells does it have? Number of electron shells is just the period number. So equals to period number. So what is the period number over here? 1, 2, 3, 4, 5. So indium will have 5 electron. So if you just go back to the question, you just write 5 over here. Okay. And then what do they ask? A sample of indium contains 2 isotopes, 113 ion and 115 ion. Complete table 2.1 to show the number of protons and the number of neutrons in one atom of each isotope of indium. So we already know that the atomic number is 49. The atomic number itself is the proton number. So it's 49 for both of them. And then they ask us to find the number of neutrons. To find the number of neutrons, all you have to do is just subtract the nucleon number with the proton number. Okay. So it's 64 and 115 minus 49. That should be 66. So 64 and 66 are the relevant numbers. Is it clear for all students? Samuel already answered, but what about the rest? Okay, Chelsea, yeah, Isabella, is it clear for you? All right, thank you. Okay, so now we have a relative atomic mass question, and this is something that you guys had raised. So let's see. Table shows relative abundances of the two isotopes in the sample of indium. Calculate the relative atomic mass of this sample of indium to 1 decimal place. Now, typically what you guys get as the relative abundance is a percentage. This one was unique in the sense that it's no longer a percentage. They just gave you numbers. They told you 1 and 19. A very common mistake that students would make is they assume that this is in percentage. So the wrong calculation, I'll show that first. The wrong calculation would be 113 times 1 plus 115 times 19 divided by 100. If you do this, you're going to get a very wrong value, a very off value. If we were to just quickly check 113 plus 115 times 9 by 100, we get 11.48. And the moment you get this, alarm bells should start ringing because here's the thing, the isotopes had a mass of 115, 113. So the relative atomic mass should be roughly close to these, definitely not 11.48. So if we now look at the correct one, and the main formula for relative atomic mass calculations should be this. RAM is equals to mass of isotope 1, so let's call it M1, times abundance. So if it's in percentage, it's going to be percentage 1 plus mass of isotope 2 times percentage 2 divided by 100%. This is if they give it in terms of percentages. Now, like this question where it's not in percentages, where rather it's in relative quantities, the formula is just adjusted in that manner. What we will instead do is just multiply the relative abundance. So relative abundance 1, relative abundance 2 divided by relative abundance 1 plus relative abundance 2. That is the formula for RAM if they give you relative abundance instead of percentage. So now how will we solve this? So when it's 113, it's 1. So 113 times 1. When it's 115, it's 19. So plus 115 times 19 divided by, so 1 and 19. 1 plus 19. So if we do this calculation, what do we get? Can you guys quickly check? Okay, yes, Samuel. 114.9. Yes. So notice something, it's very convenient that the final answer we got is already in one decimal place. We did not really have to round it or anything. 114.9. Let's say you ended up with 114.87. You will round it to 114.9. Let's say you got something like this instead, 114.97. In that case, when you round it, you should rewrite it as 115.0. That is also something you should be careful about. So, is relative atomic mass calculations clear for students? I think someone asked a question about this. I hope it is clear now. If you do have any other questions related to relative atomic mass, feel free to ask me. If not, just give a thumbs up and we move to the next part. And Chelsea, you were the one who asked the question, I think. Okay, will be fine. All right, let's move on to number 3. The salt sodium chloride, NaCl, can be prepared in the laboratory by different methods. Method 1, burning sodium metal into a glass jar. Sorry, burning sodium metal is placed into a gas jar of chlorine gas. Solid sodium chloride is formed, and they gave you the reaction. Method 2, dilute hydrochloric acid is added to a known volume of aqueous sodium hydroxide in the presence of an indicator until a neutral solution is formed. So this one is just titration. So what is the first question? State the color of the flame sodium metal burns with before it is placed into chlorine gas in method 1. So this is just the color from the list of flame tests that you have in your syllabus. Can anyone tell me what should be the answer for this one? Yes, Liat, you are correct. It should be yellow. I hope the others also know this. This is just from the syllabus list. There is nothing else that you have to know from here. You don't have to know the reaction. You don't have to know why this has this color. All you have to know is the color itself. And there are more metals. Just go through the list. And this is important for both P4, P6, and P2. So it's important for every paper. All right, next. Say the color of chlorine gas before burning sodium metal is added to it in method 1. This is from group 7. So, yeah, yellow, green. You can also write pale yellow, green, but yellow, green is also fine. Again, this is something that you will find in the syllabus itself, where it's just listed when the group 7 section starts. Okay, and next we have a moles calculation. Let's see what is given to us. Calculate the mass of sodium chloride formed when excess burning sodium metal is placed into 960 cm cube of chlorine gas at room temperature and pressure in method 1. So let's look at the equation. And So what do we have? We have the volume of chlorine gas present. And they told you that sodium metal is in excess. Whenever a substance is in excess, we ignore that substance for the remainder of the moles calculation. Our concern is always the substance that is not in excess. In this case, it's chlorine. So I will find the moles of chlorine first. Now, since chlorine is a gas and we have the volume given, all we have to do to find the moles is divide by 24,000. And it's 24,000 because it's in cm cube. So if I divide 960 by 24,000, I get 0.04 moles. So this is the moles of chlorine. Now, what did they ask for? They asked for the mass of sodium chloride. To find the mass of sodium chloride, the first thing I would need is the moles of sodium chloride. Now, how will I find the moles of sodium chloride? Notice that chlorine and sodium chloride have a ratio of 1:2. Now, what that means is if you supply 1 mole of chlorine, you get 2 moles of sodium chloride. So if I supply 0.04 moles of chlorine, I will get 0.04 times 2 equals to 0.08 moles of sodium chloride. And once I have the mass, I will recall the formula moles is equals to mass by mR, and then I will find the mass itself. So mass of NaCl should be 0.08 times the mR. Now sodium chloride, sodium has a mass of 23, chlorine has a mass of 35.5. So it's just 23 plus 35.5 for the mR. Now if you were to just calculate this, 0.08 times 23 plus 35.5. If I do this, the value that I end up with is 4.68, and this is most definitely in grams. So the mass of sodium chloride obtained is 4.68 grams. Is this question clear for all students? Does anyone have any questions regarding any of the steps here? All right, thank you for answering. Let's look at the next part. Write the ionic equation which represents the neutralization reaction that takes place in method 2. Now, it already mentioned its neutralization, so you really don't need to even look at what's happening. All you can directly write down is H plus, OH minus, H2O. And that will get you the mark. The ionic equation of neutralization is just the formation of water from its ions, H plus and OH minus. Next part, name a suitable indicator to use in method 2. Now, in your syllabus, you have a few list of indicators. Phenolphthalein, or wait, let me actually show the colors as well. We will get back to this soon, but what I will do now, show you colors. So here are the different colors of indicators that you guys have in your syllabus, and we are going through this because one of you asked this question. So I have thymolphthalein as an indicator, phenolphthalein, methyl orange, litmus paper, and universal indicator solution as a potential indicator. Now, for indicators, all you really have to remember are the colors. You don't really have to know what exactly is an indicator or what's the composition of an indicator. That is something that you will learn if you ever sit for A-level chemistry, not even AS, A-level chemistry. So you need not worry about that. What you need to remember are the different colors. So for the universal indicator solution, it's pretty straightforward. It's just the colors of the rainbow. So you start from red, go to orange, yellow, green, blue, and end with violet. And we are essentially going from very acidic or strongly acidic to strongly alkaline. So the universal indicator is generally not an issue for students. What ends up being an issue are these indicators where the colors are often quite different. So for example, for phenolphthalein, when a base is present, it's this pink color that you can see over here. When it's neutral, it turns colorless. When it's acidic, it turns colorless as well. And if you ever do a chemistry practical or a chemistry titration in real life, phenolphthalein is most likely going to be the indicator that you're going to use, mainly because the change in color is very distinct for phenolphthalein. Pure methyl orange also seems like it has a very distinct change where it's going from yellow to orange to red. But when you're doing it practically, you won't really have so much of the solution present. You won't really use this much indicator. You'll use very small amounts. And when it's small amounts, the distinction from orange to yellow and orange to red is very difficult to understand. But in the exam, if they do ask you what's the color of methyl orange in neutral solution, you will directly write orange. Regardless of how pinkish, how peachish it might look, you will just write orange. Same goes for the basic color, same goes for the acidic color. I mean, to be frank, the acidic color looks like it's pink or magenta, but in your syllabus, it stated that in acidic solution, methyl orange obtains a red color. So that is the one that you should write as well. And then thymolphthalein is a rarer one compared to phenolphthalein and methyl orange, but nonetheless, it is there. So in the acidic solution, it's colorless. In the basic solution, it is blue. And in neutral solution, it's in between. So it's neither blue exactly nor acidic. It's a very pale bluish color, or just a midpoint between the colorless and blue. So that is the color for thymolphthalein. And litmus paper, fairly straightforward. In acids, blue litmus paper will turn red, and in bases, red litmus paper will turn blue. And you have two pictures over here that will show the different colors. So yeah, that is all you really need to know about indicators and the different colors. There are other indicators as well, but in your syllabus, you only need to worry about these. And they are also listed down over here in the form of this table. So you can also read or just take a picture of this table. By the way, are all of you added to my Google Classroom? I think some of you are already there, but I'm not sure if all of you are there. Layat is there. I think, Isabella, you also have access to this Google Classroom. Yeah. The rest aren't. I will provide a link to this Google Classroom after this session, so you can just uh, access the notes from there as well. And there are also some worksheets that you can go through before the exam. All right. But does this answer your queries regarding? Yeah, all right, Samuel, I will provide a link after the class. But does this clarify your concern regarding indicator colors and indicators in general? I don't remember who asked the question. Where is it? Okay, yeah, Isabella. Isabella, does this clarify everything that you were worrying about? I hope it does. And let's move to the paper again. Okay. So over here, name a suitable indicator to use in method 2. And what were we doing? We were titrating hydrochloric acid with sodium hydroxide. So the most suitable one that I would suggest is phenolphthalein over here, mainly because there is a very distinct change in color as we go from acid to neutral, or as you go from alkali to acid. So since that color change is very distinct, phenolphthalein is a suitable indicator. You could write the other ones as well, and you would get the mark, but it's fine nonetheless. Name the experimental technique used in method 2. Can anyone tell me what's the name of the technique? Yeah, titration. I literally said it when we were discussing. So it's just titration over here. Let's move to this question. Complete the dot and cross diagram of the ions in sodium chloride. Give the charges on the ions. So what should be the charge for sodium? Students, what's the charge of a sodium ion? Yeah, plus. And for chlorine, the chloride ion, it should be minus. But the thing is, are the dot and cross diagrams complete? Like for example, for sodium, if I write down the plus charge, is the dot and cross complete, or do I have to add anything? All right, what do I have to add? Yeah, you are correctly at. You have to add the full outer shell. Now, sodium has an atomic number of 11, so it must have 11 electrons. But since this is the sodium ion, it has lost one. So the sodium ion has 10 electrons, but we can very clearly see that this dot and cross diagram only shows 2. So to complete it, you will draw another circle or another orbit, and then just draw 8 electrons as such. Okay. So this is the sodium outer shell. And same goes for the chloride ion. We see that chlorine has 17 electrons. So if it's chloride, it should be 18 electrons. It has gained one. Now, in that case, I have how many? I have 2 and then 8. So I have 10 already. I just need to, yes, I just need to add the outermost shell. And as Samuel already mentioned, it will have 7 dots, but one of them will be a cross. Now, the reason why this is a cross is because the outer shell electron that sodium had, that has been released, and the chlorine atom gained that electron. So to show this distinction that no, all the electrons in the chloride ion aren't from the original chlorine atom, we show a difference using dot and cross. Is this clear for all students? Does anyone have any questions? All right, thank you for answering. Let's move to the next part. Molten and aqueous sodium chloride are separately electrolyzed using inert electrodes. Inert means unreactive. Name a suitable inert non-metal electrode and a suitable inert metal electrode. So what could be a non-metal electrode? Yeah, graphite. Yeah, graphite, or you could even write carbon. For metal, you will write platinum. So these are the suitable substances that you could use as an electrode. If you ask for non-metal or metal, it's just graphite or platinum. All right, fairly basic questions till now. And then let's see, complete table 3.1 to show the name of the product formed at the cathode during the electrolysis of different forms of sodium chloride. So when it's molten, Isabella, can you answer this? What is the product at the cathode when we electrolyze molten sodium chloride? Sam, I asked Isabella. All right, Sam, you are correct. It's sodium, but if you write, yeah, Isabella, you are correct. You should write sodium. If you write Na, Sam, again, they ask for the name over here. So you have to write sodium, the entire thing. Just the formula would not work. You could also write solid sodium. Not really required, but you could if you wanted to. All right. The next part, dilute aqueous solution. So they made a distinction between dilute and concentrated. Chelsea, what should be the product when dilute sodium chloride is electrolyzed? Chelsea, are you there? All right. What about the rest? Arya, what should be the name of the product? Yeah, you are correct. It should be hydrogen. Also, apologies if I'm pronouncing your names incorrectly. Do let me know if I am. But yeah, okay. So that one is correct. All right, Sam. Now you can answer. What should be the product when concentrated aqueous solution is electrolyzed? Samuel, if concentrated sodium chloride is electrolyzed, should it be sodium? Does the concentration affect the cation or does it affect the anion? Yeah, Arya, you are correct. It should be hydrogen. Okay, here's the thing. Dilute versus concentrated is a factor for anions. And even then, it's for halogens versus your hydroxide. So if it's concentrated, the halogen is going to be released. If it's dilute, then the hydroxide is going to be released. At no point in time, it's going to affect the cation. The cation is not affected by the concentration. Yes, Liat, you are correct. At the other electrode, it would be chlorine gas when it's concentrated, but when it's dilute, it should have been oxygen. Does this clarify things for you, Sam? All right, thank you. Okay, so that is the end of question number 3. We are in question number 4 now. And what is question number 4 about? When hydrogen reacts with carbon dioxide in a sealed vessel at 130 degree using a suitable catalyst, methanol is produced. All right, so we are at the organic chemistry section of this paper. Sam, do you have a question? Your hand is raised.
Okay, if I unmute.
Yes, it is fine if you're on mute.
So for the cathode, if it's has lower reactivity than hydrogen, it will form at the cathode in an aqueous solution, if I'm correct, the metal.
Yes, yes.
Okay.
Like if you go through the reactivity series, you have hydrogen and then you have copper, silver, gold, and platinum. So these would be released if these were present as part of the electrolyte. But in your syllabus, most of the time, it's just copper or silver if they do give this question. Also, students, you can unmute. It's not like there's any restriction related to that. So yeah. All right. So this question gave us the equation already, and I see that the enthalpy change is minus 40 kilojoule per mole. What does this indicate? What does the negative sign indicate? Okay, let's see what question does Arya have. If they asked about the anode, would you say chlorine or chloride? Arya, we would say chlorine. We would say the molecule is released, not the ion. And yes, the rest, Layat and Isabella, you guys are correct. It is an exothermic reaction. Now, what is an exothermic reaction? It's just a reaction where more energy is released compared to energy that is used to break bonds. That is why we see the negative. This negative just means that there is a net loss of energy, meaning energy is released. Okay, so let's see. State how the information shows that this reaction is reversible and exothermic. Before answering reversible, let's answer exothermic since we are already discussing. We can just say that the enthalpy change is negative. That will suffice. You could write del H is negative. I would prefer if you write the full form, just to be on the safe side. All right, but how do we know that this is a reversible reaction? Or what would you write for this answer? That is the more important point. How would you say it's the symbol between? Yes, that you are correct. All you'd have to say is the double arrow symbol means reversible. So if you just write this, good enough. First one is about a symbol, second one is about the enthalpy change. Okay, next part. Complete table 4.1 to show the effect, if any, for each change of condition. Use only words increase, decrease, or no change. So we have two columns, one for uh, effect on the concentration of methanol, and the other one is the effect on the rate of forward reaction. So we have 1, 2, 3, 4, and we have 5 of you guys. So if you will answer, and one will let go. All right. So the temperature is decreased. When the temperature is decreased, Layat, what should happen to the concentration of methanol? It should decrease. And the reason it's going to decrease is because of this. The forward reaction is exothermic. So when the temperature is decreased, wait, Leah, should it be decreased? Because if the temperature is decreased, which side will the equilibrium shift to? Should it shift to the right side or should it shift to the left side? Yeah, yeah, it should shift to the right side. So just to quickly clarify the confusion, temperature is decreased. Now, what is happening over here is Le Chatelier's principle. And what is Le Chatelier's principle? Whenever we make a change in an equilibrium, the equilibrium will shift in a way to oppose that change. So, what did we do? We decreased the temperature. So, what will the equilibrium try to do? It will try to increase the temperature. Now, how will it increase the temperature? By releasing more energy. So, we said that the forward reaction is exothermic. That means it released energy. So, to increase temperature, it will shift to the right side. And we see that the right side has methanol as the product. So when it shifts to the right side, the concentration of methanol is going to increase. So that's increase over here. And in that case, Arya, can you tell me what will happen to the rate of forward reaction? Yes, it is going to decrease. Now, some of you might wonder that how is it that the equilibrium is shifting to the right side, but we are saying that the rate of forward reaction is decreasing. The main emphasis is on the rate. The rate of a reaction, when it's dependent on temperature, is always going to decrease if temperature decreases. So do not confuse this with the concept of equilibrium. Equilibrium shifting and rate of reaction are two different things, and this is probably the best way to see it happen. So the rate is decreasing, but the concentration of the product is increasing. All right. Next, the pressure in the reaction vessel is decreased. So, Sam, can you tell me what will happen to the concentration of methanol at equilibrium when the pressure is decreased?
Can you please show the equation again?
Oh, this is the equation. Also, I did provide a link of the paper. You should download it as well. This is the equation that we have, and we are told that the pressure decreases.
It's a decrease
Yeah, it will
in methanol,
decrease.
concentration of methanol.
So it will decrease because the right hand side has 2 moles of gas, the left hand side has 4 moles of gas. Now, it's very important that it's moles of gas and not moles of solids or liquids. So, since the left hand side has more moles of gas, when pressure decreases, equilibrium will shift to the left side to increase the pressure again. Now, why would it increase? Because if it's 4 moles, that means there's more particles. More particles means more collisions. More collisions, more pressure. That is the thought process. All right. The next part, change of condition is catalyst is removed, and what we need is the effect on the rate of the forward reaction. Isabella, can you tell me what will happen to the rate of forward reaction when the catalyst is removed? Yes, you are correct. It's going to decrease. What a catalyst does, and I think you guys should have a note of this, is basically sometimes they'll ask you explain the role of a catalyst in the reaction. So there are 3 points that you should very clearly mention. So the first one should be lowers activation energy. All right, let's switch it up. Rather, right, provides alternate mechanism 2 is lowers activation energy, and 3 is increases rate of reaction, since greater proportion of particles have energy greater than activation energy. This is what you'd write if they ever gave you a 3 to 4 mark question regarding catalysts. If it's, let's say, 1 or 2 marks, then generally just saying increases rate of reaction by lowering activation energy is good enough. But if it's a more comprehensive question, then this is what you'd write. Yes, Samuel, did you have a question?
What do you mean by provides alternate mechanism?
Oh, all right. Each
I don't understand
reaction,
that part.
when it occurs, it's not like it just directly, let's say, methane and chlorine. We know about free radical substitution, and we know that at the end, one of the hydrogens is replaced with a chlorine. But the thing is, this isn't really happening in one single step. There are multiple steps involved underneath. Like there is a step where this bond is breaking, hydrogen is removed. There is a step where the chlorine is attaching, and then there's this external step where hydrogen and chlorine are attached. So a reaction has many internal steps before you reach the final product. It's just that for IGCSE, you don't really have mechanisms, but when you do study AS chemistry, there will be way too many mechanisms that you'll have to know. Like you'll have to draw reaction mechanisms. A mechanism is just the different steps that is undergone as a reaction occurs. All right, it's like the internal process of a reaction. The equation is just the overall effect. The mechanism is the different internal steps. All right. Did everyone write this down, by the way? This is important, the way a catalyst works. Great. Thank you very much. Let's move to the next question. Figure 4.1 shows an incomplete reaction pathway diagram for the forward reaction. We have energy, progress of reaction. Complete the reaction pathway diagram in figure 4.1. In your diagram, include the formulas of the reactants and products, an arrow labeled EA to show the activation energy of the forward reaction, and then also show the enthalpy change. So EA is always from reactants to the maximum point. So this is the horizontal level for the reactants. You will draw an arrow like this. You'll label it as EA. That's the first thing. And then the enthalpy change. So that is from the reactants to the products. The reactants, and let's extend the products line. Downwards arrow, and then you write village. The most commonly done mistake is this one. Students give double-sided arrows. It is not a double-sided arrow. The arrow is very important because it also gives you an idea of the sign of the value, whether it's positive or negative. No, the dotted line is not required. Yes, you can draw it for reference. That way it will be more accurate, but it's not mandatory. And as I was saying, do not give a double-sided arrow because the arrow indicates the symbol of the value. So since for this one enthalpy change was negative, the arrow is downwards. If you give the double-sided arrow, that defeats the purpose. All right, so these are the activation energy and enthalpy changes, and they also asked you to write down the formulas of reactants and products, and this is just this reaction over here. So all you'd have to do is just copy these down over here. So 3H2 plus CO2, and it produces CH3OH and H2O. H3OH plus H2O. And when you write this down, it will be fine. All right, Isabella, which arrow needs to be double the size of the other one? Oh, I meant double-sided, like an arrow with two heads, this and this. It's never going to be a double-sided arrow. It's always going to be a single arrow with only one arrowhead. It won't have two arrowheads. All right. The sizing of the arrows, that doesn't really matter unless they tell you about values or they ask you to show the difference. But the direction of the arrow is very important, and that is what I was trying to clarify. Does anyone have any questions regarding the energy pathway diagram? If it's clear for all of you, just give a thumbs up and we move. Okay, thank you. Use figure 4.1 and the information given to determine the enthalpy change in kilojoule per mole of the reverse reaction. Include a sign with your answer. So it's asking for the enthalpy change of the reverse reaction. For the reverse reaction, just remember that now the product is going to become the reactants and the initial reactants are now products. And for enthalpy change, the rule is always go from reactants to products. So from reactants to products is just this arrow. And we can see that it's now in the opposite direction of the initial enthalpy change. So what is going to happen is it's just going to be negative del H. Now they ask for the value of the enthalpy change. And we know from the very first part that the enthalpy change was minus 40 previously. So if it was minus 40 previously, now it's going to be minus 40. So it's just plus 40 kilojoule per mole. Is this clear for all students? Okay. And then the activation energy in kilojoule per mole of the reverse reaction, include a sign with your answer. Now, the activation energy is always from the reactants to the peak. So this time the reactant is this level. And from the reactants to the peak, if we check the height, there's two parts involved. There's the enthalpy change, and then there's the old activation energy. So if I just write an equation like this, activation energy or new activation energy is equals to old activation energy plus new del H. So the old activation energy, if you were to look, was 220 kilojoule per mole. Kelsey, do you have a question? You're unmuted.
No.
All right,
The question.
that's fine. Okay, so the old activation energy was 220 kilojoule per mole, and the new enthalpy change we just found in the previous question is 40. So 220 plus 40, so the new activation energy is just plus 260 kilojoule per mole. For these energy questions, even if they do not ask for a sign, I would suggest give a sign because it is important. Like sometimes they won't specify that the sign is required, but you would end up getting a negative value. You must show the negative sign if you do get one. And even if it's positive, write down the positive. It's not really going to take that long if you write the sign. Is it clear for all of you how I found the activation energy and the enthalpy changes? This is a very common question, and you could expect this in your exam as well. All right, so now we have a question where it's related to bond energies. So let's see. Equation of the reaction of hydrogen with carbon dioxide can be represented as shown in figure 4.2. So these are the reactants, and these are the products. And it's the same reaction as the first one. So let's see. We have different bonds and their bond energies are provided as well. Let's see. Use the bond energies in table 4.2 and the value of enthalpy change for the forward reaction to calculate the CH bond energy in kilojoule per mole. Use the following steps. Calculate the energy needed to break the bonds in the reactants. So in the reactants, what do we have? I have three hydrogen-hydrogen bonds and I have two carbon-oxygen bonds. So the bond energy of the reactants is just 3 times hydrogen-hydrogen, which is 440, plus 2 times carbon-oxygen double bond, so 805. Can anyone quickly calculate and let me know what value we get? Yeah, 2930 is correct. So 2930 is the energy that is needed to break the bonds in the reactants. And then let's see the next part. Calculate the energy released when the bonds in water form. So how many bonds do we have in water? 1 and 2, and both of them are just oxygen, hydrogen, single bond. So that's 460. So 460 times 2, and that is simply 920. Now they ask us to calculate the bond energy of the carbon-hydrogen bond. Now, let's say you are a bit clueless as to how you're supposed to get to carbon-hydrogen bond. Just try to form an equation using this idea. We know that enthalpy change is reactant bond energy minus product bond energy, or basically reactant minus product. So we already know the reactant bond energy as 2930. So let's try and form an equation. Minus 40 is equals to 2930. That's the reactant bond energy minus the product bond energy. So now I already included the water. So that's 920. So minus 920. And then I have to include the methanol. Now over here, what are the bonds present? I have one OH bond again, so minus 460. I have one carbon-oxygen bond. So carbon-oxygen single bond is 360, so minus 360. And then I have the three carbon-hydrogen bonds whose bond energy we do not know. So what I can do is I can write them down as minus 3x, since I'm going to subtract this. Does this equation make sense to all of you? The way we found this, all we did was enthalpy change is equals to reactant bond energy minus product bond energy. So now all we have to do is just solve for x. So before solving for x, it's important we simplify it as much as possible. So minus 40 is equals to 2930 minus 920 minus 460 minus 360. So that's 1190 minus 3x, or if I bring 3x to the left side and take minus 40 to the right hand side, it's 1190 plus 40. So that's 1230. Therefore, x is just division of this, and we end up with 410 kilojoule per mole. So that's the bond energy of carbon hydrogen over here, 410 kilojoule per mole. Is this process clear for all of you? The main formula over here is enthalpy change is reactant minus product, and then you just form the equation using the relevant bond energies. All right, thank you for answering, students. Let's move on to the next part. And what do we have over here? In figure 4.3, complete the dot and cross diagram of a molecule of methanol. The good thing is they already gave you the structure, or they gave you the structural formula. They told you that single bond, these are all single bonds. This is also single bond. So it's only single bonds involved. And that makes our life much easier. All you'd have to do is show a single bond. So single bond will have one electron each from each atom. So two like this, two like this. And then the carbon and oxygen will have another one like this. And lastly, two circles like this. So over here, the crosses represent the electrons of carbon and the dots represent electrons of hydrogen and oxygen. So the dot and cross diagram is fairly straightforward since it's all just single bonds over here. Does anyone have any questions?
What about the lone pairs of
Oh,
oxygen? The
yes,
two
you are
lone pairs?
correct. You are correct. You should give the lone pairs of oxygen as well, because we see that how many have we used for oxygen? 1, 2, and 3. So oxygen has 6 in its outer shell. So I need to include those as well. That's a good point that you have raised. So 1, 2, and wait, 3 and 4. Just to make a distinction, this one, the blue one is for hydrogen and the red one is for oxygen. So 1, 2, 3, 4, 5, 6. Yes, Samuel.
In the exam,
Hmm.
should we make the hydrogen bonded to oxygen across rather than a dot so
You
they can see the difference between the two molecules, electrons?
you could, but again, like here's the thing. For this hydrogen over here, you used a dot. So It's fine if you use a dot over here or a cross. Since in this question we were using crosses to represent carbon, it's not really going to make much of a difference because one way or another there is going to be a confusion. So they will give you the leeway and you'll be fine if you use dot or cross for that last one, right? All right. Ethanol is a common fuel. Methanol can be used as a fuel as well. Okay. Complete and balance the symbol equation for the incomplete combustion of methanol. Now they mentioned incomplete. That means it's not excess oxygen. And combustion is always reaction with oxygen. So this is just O2 over here. That's the first thing that you should write down, and then you should approach the balancing. So over here, notice that I have 4 hydrogens over here. So to balance it, I just write a 2. So now I have 2 hydrogens, and the last part is checking if the oxygen is balanced or not. And if we do check it, I have 1 and 2 over here. So that's 3 oxygen, and on the left hand side as well I have 3, and carbon is already balanced because I have 1 of each. So the balance equation for incomplete combustion is just this, and they didn't ask anything about state symbol, so you need not worry about it. Is this clear for all students? All right, thank you. So that's a question worth 19 marks, and I believe we are near to the end of the paper, and the last few questions are going to address some questions related to esterification and some questions related to polymerization. So let's see what do we have over here. A, B, C, D are first 4 members of a family of organic compounds with similar chemical properties. Table 5.1 gives either the molecular formula or the name of A, B, C, and D. So we have A, B is ethanoic, C is propanoic, D is butanoic. Say the term given to a family of organic compounds with similar chemical properties. What is the name?
Homologous series.
Yeah, it is a homologous series. And in your syllabus, it's very important for you guys to know 4 characteristics of a homologous series. You will find it in your notes as well as the syllabus. Let me just show you where you should be looking for. So we'll take a quick detour and look at the syllabus. So if you look at the syllabus and if you go all the way down, search for the organic part, these. You will sometimes have confusions that what part am I supposed to include for characteristics, or what am I allowed and what am I not allowed to write down. These are the points that you're allowed to write down. These points from A to E. So what are the points? They have the same functional group. They have the same general formula. They differ from one member to another by a CH2 unit. They display a trend in physical properties. The physical properties are melting point, boiling point, viscosity, and what was the other one? Wait, do any of you remember the other one? It was related to it vaporizing. I forgot the exact term that we used to call it. Melting point, boiling point, viscosity. There was a fourth one. It was, oh, volatility, right. Volatility is just the ability to vaporize. Most of the times, if you just remember melting and boiling point, you will be fine for the paper because they won't really ask about all 4 of them. But I have seen a few papers where they write down all the physical properties. So at that point, you're bound to use the remaining one, which is usually viscosity or volatility. So even though it's not really directly written in the syllabus, it's just vaguely written as physical properties. These are the 4 physical properties that you should be writing about if you're ever asked for this. Melting point, boiling point, viscosity. Viscosity is just the thickness of the fluid or the ability to flow. Volatility is the ability to vaporize. So these are the four physical properties. And then E is just a repetition of the fact that they have the same functional group. And due to having the same functional group, they have similar chemical properties. So these five are the characteristics of the homologous series. But to be honest, I would say write down the first four if they ever ask you about characteristics, because similar chemical properties is just an explanation or is just a cause of having the same functional group. Is this clear for all students? All right, all right, that's fine. But can anyone tell me what's the trend in melting point as we go down a homologous series or as we increase the number of carbons in a homologous series? What happens to melting point? Yeah, it increases. But why does it increase? Higher melting point, the longer the chain gets. Yes, both of you are correct. But can anyone tell me why does it increase? The energy required increases as chain lengthens. All right. But why does the energy required increase? Exactly, Samuel. You are correct. The intermolecular force increases. Now, why does the intermolecular force increases? It's because as the chain length increases, that means you have more carbon and hydrogen. And what do these contain? They contain electrons. The idea is if the number of electrons increases, then the intermolecular force also increases. As a result, melting point and boiling point increases. Is this clear for all students? This is important. All right. Okay. And then for viscosity, the thought process should be this. If it's a smaller chain, like let's say it only contains two and they're stacked over here, they won't really interfere with each other. But let's say you have a longer chain. I mean, just drawing random stuff at this point. But the idea is if it's a longer chain, we can see that it's getting tangled and whatnot. And when it gets tangled, it's difficult for the molecules to flow on top of each other. As a result, the longer the chain, the more viscous the liquid. And the point for volatility, ability to vaporize, is just related to the boiling point. Higher boiling point, lower chances of it vaporizing. So, does this answer your queries regarding homologous series? All right. Yes, Samuel.
Could you just repeat the train in viscosity? I just missed it.
Oh,
I glitched out.
like for viscosity, think of it in this way. Viscosity is the ability of the liquid to flow. It's basically the thickness of the liquid. So think of it in this way. You have a small chain. So these molecules represent the small chain. And then you have a large chain. Like let's say I'm just drawing random carbons. And then you have another molecule of the same size. Now, you tell me, Samuel, if it's this long chain, isn't it more likely that they will get tangled on top of each other or tangled with one another compared to these small molecules, which are generally not interfering with each other as much? So, due to this fact that longer chains interfere with one another while smaller chains do not, smaller chains are less viscous compared to longer chains. Is that clear, Samuel?
Yes, thank you.
All right. So that is basically all you really have to know about the homologous series. So we can now move back to the paper that we were solving. So explain why members of a family of organic compounds show similar chemical properties. And we already discussed this when we were going through homologous series, and we said that it's due to them having the same functional group. So all you have to write down is they have the same functional group. And then state the general formula of the family of organic compounds in table 5.1. So what are the compounds in table 5.1? All of them are carboxylic acids. So all you have to do is write down the general formula of carboxylic acids. Can all of you try write it down in the chat box? general formula of carboxylic acids? CnH2n plus 1 COOH. Yes, yet you are correct. CnH2n plus 1 COOH. So this is for carboxylic acids. You guys are also required to know the other general formulas. Let me just write them down as well. So for alkanes, it should be CnH2n plus 2. For alkenes, it should be CnH2n. For alcohols, it's CN H2n plus 1 OH, and we already wrote down for carboxylic acids. So these four general formulas are very important for IGCSE. Once you go to AS, you'll realize that general formula is something that doesn't really even exist because it's very rare for you to have compounds with only just one functional group. So when there are multiple functional groups involved, the general formula completely breaks down. But for IGCSE, this is something that you guys are tested on. So are the general formulas clear for all students? All right. So the next part is table 5.2, and what we are asked is to write down the name of A and the structural formula of B, C, and D. So A was a carboxylic acid consisting of one carbon. So if it's one carbon, that means it's meth. So the name format for carboxylic acids is alkanoic acid. Alk being the prefix. So since it's one carbon, it's meth, so it's methanoic acid. And then the structural formula of B, C, and D. B is ethanoic acid. So all we really need to write down is CH3 CO2H, or you could write COOH like this. Since it's methanoic acid, it will have two carbons. And for the other ones, all you have to do is just add CH2 in the middle. So CH3, since it's propanoic acid, it will have three carbons. So CH2 in the middle, COOH. And remember, when we were discussing characteristics of the homologous series, what did we say? They differed by CH2. And that is what we are saying. As we go from one to the next one, it's getting a CH2. And the last one, D, was butanoic acid. So CH3, CH2, and it's going to get another CH2 now, and then COOH. So these are the structural formulas for B, C, and D. And the good thing is, since they are part of the same homologous series, all you really had to do was just add CH2 in the middle. Is this clear for all students? All right, let's move on to the next question. Is it not asking for molecular and empirical formula? Oh, right, right. Good thing, Liat. It did ask for molecular. So if we just quickly do the molecular formula, apologies for the error, C3 and the number of hydrogen, 3, 2, and 1. So 6 hydrogen, 8, 6, and O2. So this would be the molecular formula of C. Erase this quickly. That is an important thing. And then it asks for the empirical formula of D. So to write down the empirical formula, we will utilize this. So C4, and how many hydrogens do we have? 3, 2, that's 5. 5, 2, that's 7. 7 and 1, that's 8. So H8 and then 2O. So C4, H8O. Now, how do we find the empirical formula? We just divide by the smallest possible number, or basically the common factor. So in this case, 2 is the common factor. I will divide everything by 2. If I divide 4 by 2, that's 2. If I divide 8 by 2, that's 4. If I divide 2 by 2, that's 1. So the empirical formula is C2H4O. So the first one asks for the name, second one asks for the structural formula, third one asks for the molecular formula, fourth one as for the empirical formula. Thank you for letting me know, Liat. That was a good observation. All right. Does anyone have any questions regarding the changes we have made? If so, we can go through this again. No hands. Let's see. So E is asking about this. C is made by oxidation of an alcohol. The oxidizing agent used has the formula KMnO4. So what was C? C was propanoic acid. So they're saying it's made by the oxidation of an alcohol. So to get propanoic acid, we would use an alcohol that has the same number of carbons. So what is an alcohol containing 3 carbons? It's just propanol. But over here, instead of writing propanol, I want you guys to specify it's going to be propan 1-ol, because when you go to AS, you're going to learn about this, that only certain alcohols can be oxidized to a carboxylic acids. But even in this stage, just know that it's going to be propan 1-ol that is going to give you propanoic acid. If by any chance you do write propan 2-ol, that would be wrong. Writing propanol would be ambiguous because it could mean either propan 2-ol or propan 1-ol. Sometimes it's assumed that if you don't write a number, it's always the first one. But to be on the to be on the safest possible side, write down propan 1-ol. Okay. The next part, give the chemical name of KMnO4. This one is just straightforward. Potassium manganate. Now, is this the full name or am I missing something?
I think it's potassium permanganate.
Yes,
Seven.
you could write permanganate, or you could write after the manganate 7. The 7 is essentially meaning permanganate. So you could write potassium manganate 7, or you could write potassium permanganate. Okay.
Sorry.
Yes.
Would that affect in any way if we didn't write the 7 and we just wrote the potassium manganate, or is that
If you
up
just
to
write
the
down potassium manganate, the thing is the oxidation number isn't really specified. Now, manganese is a transition element, and we know that transition elements can have variable oxidation states. So when we are writing the name of transition element compounds, we always try to specify the oxidation state, because let's look at another example. Copper oxide. Copper oxide can have two formulas, CuO or CuO2, or sorry, Cu2O. The two mean very different things because they have different oxidation states. For example, this one has an oxidation state of +2, whereas this one has an oxidation state of +1. This one is copper 2 oxide, and this one is copper 1 oxide. So for transition element compounds, it's very important you make this distinction of the oxidation state or the oxidation number of the transition element. All right. The 7 is important over here. Either you write the 7 or you write permanganate. Personally, I would prefer if you write the 7. That is probably the wiser approach. Okay. Next part. State the two conditions needed for oxidation of alcohol in 5E1 with KMnO4. Arya, can you answer the first one? What should be the condition? Is heat is required. Instead of saying just heat, I would have you write heat under reflux. That would be more appropriate. For oxidation, we heat it continuously until it has completely reacted, so that none of the alcohol remains and all of it is converted to carboxylic acid. And in that case, what should be the second condition? Can anyone else answer? In the presence of an acid, or you could write acidified. Both are fine. I would just write down acidified and save time. And the reason it's acidified is to ensure that any impurities, no, yet it's not excess potassium manganate, rather it's acidified potassium manganate. That's the important part over here. And the reason it's acidified is due to two things. One of them is to prevent any impurities present. The other one is to prevent any compounds that could potentially interfere with the reaction. And I think we went in depth regarding this, where one of it was MnO2, the other one was Mn2 plus. MnO2 would interfere with the results of the experiment. Mn2 plus wouldn't. This one is a precipitate. This one is part of an aqueous solution. But this idea is not really required at your level, so you need not worry about it. All you have to remember is the KMnO4 that we use has to be acidified. All right. The next part, D reacts with ethanol to form an ester. So now we are going to discuss the ester question, or someone did raise the question about ester. So state the type of catalyst needed for this reaction. Now what was D? D was butanoic acid. So an acid and an alcohol, they react to form an ester. And an ester is just a sweet smelling compound. And esters are very commonly used for perfumes, for solvents, not fuels. So if you are ever asked about what is the purpose of an ester, do make that clarification. All right, and so what do we have? State the type of catalyst needed for this reaction. What should be the catalyst? And they mentioned type. They did not ask for the name of the catalyst, they asked for the type. So we have to be careful about that as well. Yes, an acid catalyst. Now, Layat, when you write acid catalyst, I would prefer if you write concentrated acid catalyst, because that's the type of acid that we are using. Concentrated acid catalyst. Now, the reason we are making this distinction is because the esters, they can be hydrolyzed. Esters can be hydrolyzed. And when we hydrolyze esters, we either use dilute acid or dilute alkali. So the thing is, when you write an acid catalyst and you're not clarifying whether it's concentrated or it's dilute, it keeps this ambiguity that after the ester is produced, whether the ester is being hydrolyzed or not, or whether you're actually using the right acid. If it's not concentrated, then the ester wouldn't even form. And here's why. Because if you look at the reaction, butanoic acid and ethanol, let's write this down as well. It will form your ester and it will form water. When water reacts with ester, it breaks down the ester to give you back the butanoic acid and ethanol, and that is signified using the reversible reaction. So the thing is, if the water isn't removed properly, at the end of the reaction, the water is going to interfere with the ester. So to get rid of this water, that is why we use the concentrated acid. The concentrated acid gets rid of the water and it ensures that the ester is properly obtained at the end of the reaction. All right. So that answers that part. Now let's move on to number 2. Complete the word equation for this reaction. So butanoic acid and ethanol. So the naming format for esters is alkyl alkanoate. Now, which part is due to which substance? The alkyl part is due to the alcohol. The alkanoate part is due to the carboxylic acid. So over here, what is the alcohol? It's ethanol. So alkyl is just ethyl. Alkanoate is due to the acid. So it's butanoic acid. So it should be butanoate. So ethyl butanoate is the ester produced in this reaction. And we will also draw the ester very soon. For now, we just need to know the naming. So alkyl alkanoate is the naming format. And as we already know, water is the other byproduct. Can anyone tell me what's the type of this reaction? If they asked you, write down the type of reaction, what would you write down?
Condensation polymerization.
Not polymerization, it's just a condensation reaction. Condensation polymerization is a different thing, and it requires different reagents as well. This is just a condensation reaction. Now, before we go to the next part, I want to discuss a bit more, since some students did have confusions regarding esters. Well, that's fine, Samuel. So it's a condensation reaction. And how do we know a reaction is condensation, or how do we know whether it's addition, substitution, or any of the others? A condensation reaction always has a small molecule produced at the end of the reaction. So yes, you have your ester, but you also have a small molecule. And there is a reason I'm saying small molecule instead of water, because eventually, as you go through more advanced levels of chemistry, you will also see that sometimes HCl is also formed. Sometimes ammonia is also formed. So for all those cases involved, we say a small molecule is produced instead of saying water is produced. It means the same thing, it's just more appropriate that way. The condensation reactions are reactions where a byproduct or a small molecule is released at the end of the reaction. Now, just to clarify one more thing, since we did raise condensation polymerization, I have one question. Let's say we have 100 grams of a polymer, or no, let's make it even bigger. We have 100 kilograms of a monomer, and we are told that this monomer undergoes condensation polymerization to form a polymer. So the mass of the polymer produced, is it going to be greater than 100? Is it going to be equals to 100? Is it going to be less than 100? Or is it going to be all of the above, where it's not fixed at all? It could be either one of them. Can anyone answer this question? A monomer undergoes, yes, Liet, you are correct. You're saying it's going to be less. Now, do the others agree as well, or do you have alternative answers? Equal, greater? Okay, Samuel says he's fine with less. What about the rest? Isabella, Arya, Chelsea? Okay, Chelsea agrees, Arya agrees. What about Isabella? All right, all of you agree. Now, students, don't feel like you're being forced to agree to the answer. You can have contrasting opinions. All right, so M is going to be lower, and the reason why this is the case is because of the byproduct, because of the water molecule produced. So in the exam, if they do ask you that, what happens to the mass or why is it lower, then all you have to say is a small molecule or a byproduct or water molecules are produced after the esterification process. Is this idea clear for all students? All right, thank you, students. Okay. So the next part is draw the displayed formula of the ester formed. So the ester formed is ethyl butanoate, as we already know the name. To form the ester, the first thing you should do is just draw the alcohols and acids separately. That is something that you will eventually know that you can just skip and directly draw the ester. But in the initial stages, if you feel like you're not really confident drawing it in one go, then draw it in two steps. So alcohol and just and it's butanoic acid, so it's going to be COOH, CH2, H2. So I have my ethanol and my butanoic acid. Now, during polymerization, what happens is the alcohol gets rid of the H and the carboxylic acid gets rid of the OH. Now, I have a question for you, students. We know that acids are substances that release H plus. Why is it that the carboxylic acid is releasing an OH while the alcohol is releasing an H? does this mean that the alcohol is actually an acid and the acid is actually a base in this reaction? Did all of you understand my question? If you want, I can repeat the question, or if you don't understand, then just raise your hand and we will discuss this.
Could you rephrase the question,
All right.
please?
Basically, what is an acid? An acid, according to your syllabus definition, is a proton donor. Basically, it releases H plus. And what's a base or an alkali? It releases OH minus. Now let's look at this. I'm saying that the acid is going to release OH and the alcohol is going to release the H or the H plus. So anything that releases an H plus is called an acid. Anything that releases an OH minus is called a base. So my question is, in that case, are we saying that the carboxylic acid is actually a base and the alcohol is actually an acid? Is that the case?
No. I would say no.
Okay. So Chelsea is saying no, it's not the case. But why is that the case? Why are we saying that the acid, they don't freely exist? So it would react by rearranging bonds instead. So no, in this case, it's still an acid. Yeah, you are correct. All of you are correct, or your interpretation of the question is correct. The simplest possible way of answering this is just by saying that this isn't a neutralization reaction. This isn't an acid-base reaction in the first place. And as Leah already mentioned, that the ions aren't freely available as well. Rather, it's being released due to the two molecules interacting with each other. Whereas in an acid-base reaction or a neutralization reaction, the ions would be freely present in the solution. Whereas here, it's part of the molecule, and due to the two molecules interacting with each other, then the two portions are released. So no, this isn't a neutralization reaction. No, the acid is not a base in this case. And no, the alcohol is not behaving as an acid. This isn't an acid-base reaction, to summarize. So the ester that you have to draw is just a simple one. So you erase those parts and you join it. And that's your ester. And a very important thing that I haven't really mentioned is the displayed formula. A displayed formula requires you to show every single bond. When I say every single bond, I mean every single bond, and even the most trivial ones. The most common mistake is this one. Can anyone tell me what's the mistake over here? I asked for the displayed formula. What's wrong over here? Exactly. The OH. The OH should have the single bond between oxygen and hydrogen, also shown. Yes, Liat, you are correct as well. You have to show the single bond. But over here for the ester, that is not really an issue because that isn't really there. So for the ester, you are not really going to make the mistake. So if I just check, 2 carbons from your alcohol, 4 carbons from your acid. So that is basically how you draw the discrete formula of the ester. No, it does not matter because here's the thing. If I just take this structure and rotate it slightly, now the carboxylic acid comes first and the alcohol comes second. So it doesn't really matter. But what matters is the number of carbons that you associate with each section. The alcohol section, basically this part, will have 2 carbons since this was from ethanol. And the acid section, basically the section that contains the carbon oxygen double bond, that has 4 carbons over here since the acid had 4 carbons. If you can show this properly, then it's fine. It doesn't matter which one comes first, which one comes second. All right. So that is question number 5 of 16 marks. And we are at the last question of the paper. And the last question is related to polymerization. So let's see, what do we have? Polyamides are condensation polymers. Proteins are natural polyamides formed from amino acid monomers. Figure 6.1 shows part of the structure of a protein. So this is the structure. Deduce the number of different types of amino acid monomers needed to make part of the protein shown in figure 6.1. So let's look over here. Our goal is to break down the amide linkages. All right, Samuel is saying there's three. Let's see if that is the case. So I'm going to break down this amide linkage. I'm going to break down this amide linkage. And once we have broken them down, I have to check how many amino acid groups do I have. I have this one. I have this one, two. I have this one, three. So we would write down three over here. Does everyone agree with the answer that Samuel and I have given? It would be three types of amino acids. Right? Isabella agrees. Arya agrees. Chelsea. But what about Liat? Liat, should it be three amino acids? Exactly. You are correct. It is going to be two. Because students, look at this one. All of you took the bait. 1 and 3, aren't they the same thing? And how would you understand? Look at the box in the middle. Same box. Whereas the one that was for 2, that had a different color, or that was like slightly shaded. So when the box is the same, it means it's the same amino acid. So over here, at the end of the day, you have two types of amino acids. Yes, you have three amino acids, but two types of amino acids. The answer for this one is 2. Is this clear for all students? All right. What about Samuel? Okay, thank you. All right. Deduce the number of water molecules produced when part of the protein shown in figure 6.1 forms from amino acid monomers. For this one, all you have to do is identify the amide linkages formed over here. So I have one over here and another one over here. So I have two amide linkages, 1 and 2, and each one is going to cause the removal of one water molecule. So since I have two, I'll just say two water molecules are released over here. Is that clear for all students? All right. Now, do not think that this too is related to the types of amino acids. That is not the case. Rather, it's related to the number of amide linkages present over here. Okay, next. Complete figure 6.2 to show the general structure of an amino acid monomer. R represents the side chain. Show all the atoms and show all of the atoms and all of the bonds. So an amino acid contains two things, amine and a carboxylic acid. So those are the two things that we will draw first. So carboxylic acid, COOH, amine, so H, and nitrogen can have three bonds, so another H over here. And the carbon, the remaining bond, is associated with a hydrogen. Uh, does any student have biology as well, IGCSE biology? If you have, then I think you have also studied about amino acid structures in there as well. All right, all of you do have bio except Samuel. Okay, that's fine. Then amino acids is something that you should also know from your biology. All right, so let's see D. Figure 6.3 shows part of the structure of a different polymer. So it's changed, but notice that the linkage is still the same. It's still an amide linkage. Now, what do they ask? Deduce the number of repeat units shown in figure 6.3. Whenever it's an identifying repeat unit question, always just break down the linkage. So over here, we know that it's an amide linkage. I see that this is an amide linkage. I will break it down. I see that this is an amide linkage. I will break it down. Another amide linkage. I will break it down. And once you have broken it down into the different monomers, now I can start counting. So how many repeat units do I have? And another thing that you should notice is this part are different. And so, how is it starting to repeat? The repetition is a bit unique over here. Unique in the sense that this entire thing and this entire thing is repeating. So even though we had 1, 2, 3, and 4 monomers, the number of repeat units is going to be 2. 1 for this one, 2 for this one. Because the dicarboxylic acid, this part is called a dicarboxylic acid, and this part is called a diamine. To form a amide or a polyamide, we need a dicarboxylic acid and a diamine, or we need an amino acid. So one repeat unit over here consists of 1 dicarboxylic acid and 1 diamine. The two of them combine to form a repeat unit over here. So for this question, the answer should be 2. Is this clear for all students? All right, thank you very much. And then name 2 types of organic compounds needed to make the polymer shown. And I have already answered this. So dicarboxylic acid and diamine. Now this is for polyamides. For polyesters, since we are talking about condensation polymers, for polyesters, what you will require is a hydroxy carboxylic acid or dicarboxylic acid plus a diol. And what is a hydroxycarboxylic acid? Think of it as an amino acid where the amine group is replaced with an alcohol group. So something like CrCOOH, an alcohol group, and an H like this. This would be your hydroxycarboxylic acid. And a dicarboxylic acid is just this, and a diol is just CH2OH. So you will either need a pair of dicarboxylic acid and diol, or you will need a hydroxycarboxylic acid. And at the end, you will get a polyester over here. And students, that is basically the end of this paper. So if we were to just check, let's see. So have we covered homologous series? Does anyone have any other questions related to homologous series? If not, just raise your hand and I will place a tick next to homologous series. All right, a thumbs up also works. Yeah, I think thumbs up would be better. All right, so homologous series done. Esters, any more questions related to esters? If not, just give a thumbs up and we give a tick. All right, esters. We haven't gone through the greenhouse effect because this paper didn't ask about it. And then reactions of alkanes and alkenes. Over here, we went through some, or basically like the hydrogen reaction. Now there are more free radical and then the alcohol formation reaction that is also there. We went through polymerization. Now for polymerization, we went through condensation polymerization. We haven't gone through addition yet.
Sorry, could I ask a question about condensation polymerization?
Yes, ask.
Can you show me the difference between an amide linkage and an ester linkage?
All right. Yeah, sure. Now, I won't show the middle groups because they aren't really significant. An amide linkage is going to look something like this. Now, this is formed using dicarboxylic acids. And an ester linkage, or basically this one is your amide linkage. Your ester linkage, it's basically the same group as esters. Ester linkage will have this, an amide linkage will have this instead. This is the main difference between an amide linkage and an ester linkage. Ester linkage is due to acid and an alcohol. Amide linkage is due to an acid and an amine. All right, Chelsea?
Yeah, thank you.
All right. So we are done with condensation. We have addition left. Relative atomic mass questions. Do you have any other questions related to relative atomic mass? Also, the definition of relative atomic mass is important. Do practice that as well. If not, we place a tick next to relative atomic mass. So can I do that? All right, Leah says it's fine. Isabella, okay. And then number 7, indicators for acid and bases. Was there any other parts mentioned over here? I think we went through the colors and everything. So does anyone have any other questions related to indicators? If not, I place a tick. So just to quickly check, we went through all of these. We are left with the greenhouse effect, some organic chemistry reactions, and some part from polymerization. And I also want to show you guys some stoichiometry questions. So the remainder of the topics that we have, we will go through these. Sorry for going. What is the definition of relative atomic mass? Okay. So for relative atomic mass, RAM, there are many ways to write this. The one that I would suggest you write is it is the weighted average mass of all the isotopes of an element relative to 1/12 of the mass of a carbon 12 atom. This is the weighted average mass of all the isotopes of an element relative to 1/12 of the mass of a carbon 12 atom. This is a bit more advanced compared to what you might have learned for relative atomic mass, but this is the most accurate one. So you wouldn't be at loss if you don't use this, but if you use this, it's better because if you do sit for AS chemistry, this is the one that you're going to use. And another thing that I need to do now is add you guys to the Google Classroom link. I could send you a link, or you could just check the classroom code. So let me show that while I also share the link. Just a second. All right, so it's for 2026 IGCSE. Invite link. I'm sending this link to the parents group. Your parents will have the link as well. And in case you just want the classroom code, what you can do is the code. Just a second. The classroom code, if I just write it down in the chat box, it's BIJH6EJW. So this is the Google Classroom code. If you just write this down, you should be able to join the Google Classroom. All right. I've also sent the link in the parents group. In the Google Classroom, you will mainly find topical worksheets and you will find notes, the notes that I use when I'm teaching my regular batches. You can go through them. But I think at this stage, before the exam, you don't really need to go through notes. You're better off going through past papers, using the syllabus as the resource, and just going through marking points every now and then. So, yeah, that will be it for today's session. We have another session scheduled on Monday, and we are going to utilize Monday's session to go through these chapters. And in the meantime, I want you guys to go through more past papers so that if you do have more queries, you can all compile them before Monday's lesson so that we can discuss them in class. I feel like today's lesson was productive because we did cover a lot of ground while also covering the Feb March 2026 paper. So I think this was beneficial for all of you. And another thing, students, we are conducting sessions for mathematics. I'm not sure if you're going to conduct session for physics. My colleague mentioned that he might take them, so he'll confirm whether he takes them. But we are having session for mathematics tomorrow. I believe it's at 5 p.m. South African night. So you are all welcome to join those sessions as well. You have IGCSE mathematics, which I think all of you do. And also a reminder that we have another session on Monday. Please do join them, especially if you didn't get your topic discussed today, because we are going to discuss that and more topics and also give you some last minute tips and tricks for your exam. So if you don't have any other questions for today, we can conclude it over here and I will see you guys on Monday at 6 p.m. All right, students?
Yeah. Sorry, could I ask just one last
Yes,
question?
ask,
Well,
ask.
I just want to confirm. So the neutral color isn't always the endpoint color in a titration,
Oh,
correct?
yes, that is a good thing to ask. Neutral point versus endpoint. The two of them are different. The endpoint is basically when the indicator changes the color. Okay. It's not necessarily always the neutral point, or it's not necessarily always pH 7. The endpoint can be at, let's say, pH 4, it can be at pH 5, sometimes it can even be at pH 11. So it's not exactly the neutral point, but in an experimental scenario, it gets the job done, or it's close enough that it doesn't really matter at that point. All right.
Thank you very much.
You're welcome. Does anyone have any other questions? You are always welcome to ask.